At the University of Minnesota in the early 90s, a routine campus IT meeting erupts into frustration and sets off the creation of an internet system that almost became the web we use today. Within 2 years, it's running on more than 7,000 servers. The White House adopts it as its official online outlet, and even the creator of the URL uses it to distribute early versions of the World Wide Web. Then, it fades.
The protocol was super simple. So
anybody could write servers and clients.
Only to resurface decades later as the foundation for a minimalist internet movement still active today. How did a failed campus IT meeting almost create the rival to the modern internet, and how did it disappear? At the University of Minnesota, leadership is planning a new campus-wide information system. The proposal follows the same pattern as previous projects: another large mainframe build, expensive to maintain, and managed by a small administrative team. It will be slow to update, tightly controlled, and difficult for ordinary users to navigate.
They had one design, but it didn't look codable, at least when I said, Farhad, why don't you code this up?
I said, there's no way I can code that up.
Mark McCahill, a campus systems programmer at the university's Microcomputer Center, sits through the planning discussions and watches the system grow more and more complex. After the meeting, Mark and a small team of developers decide to test an alternative instead of debating it in the meeting. They assemble a prototype, a plain text menu, navigable with arrow keys, and able to link information on servers anywhere on the network. It requires no training, bypasses the mainframe bottleneck, and lets departments publish their own material without routing everything through a central system. They present the prototype at the next planning meeting, and according to the team, this becomes the worst meeting in Minnesota. Administrators push back immediately and yell in the meeting, "You can't do that," and "This isn't authorized." The team argues that the system already works and that students are enjoying it, and it demonstrates that the campus doesn't need another monolithic mainframe project. At one point, they're even instructed to stop development. However, they ignore the order, return to their offices, and continue building. Gopher, named for both the university's mascot and as a pun on Go For, has begun. It is an antidote to a rigid system that a small team of engineers believe will hold the campus back, and what happens next is something no one in that room expected. The team quietly uploads the Gopher client and server to an FTP directory. No announcement, no plans to distribute. However, almost immediately, administrators from other institutions find it. The University of Minnesota begins receiving emails from people they've never met. The emails state things like, "How do we add a menu item?" Or, "Our students are using this. What's next?" For the first time, the small team watches software they created spread across the internet on its own. It grows faster than anything they've released before, and the appeal is clear. Gopher turns a command-driven internet into something you can browse. It reduces dependencies on mainframes and decentralizes publishing. You can even run it on inexpensive machines that anyone can deploy. What started as a workaround for one campus monolith becomes something much larger. Gopher's growth is explosive. Traffic increases by nearly 1,000% annually, and by late 1993, Gopher reaches roughly 7,000 servers worldwide, more than 2.5 times the number of early web servers. Millions of people use it to navigate the internet. Major institutions adopt it quickly as well. Universities rely on Gopher for campus systems and research. Libraries publish catalogs and digital collections. Even federal agencies, including NOAA, NASA, and the U.S. Geological Survey, use Gopher to distribute data. Even the White House stands up its own Gopher server, hosting press releases, policy documents, speeches, and public contact information. For a time, Gopher is the White House's primary online interface. GopherCon 1992 and 1993 confirmed the system's influence. Attendees include Alan Kay, a pioneer of graphical interfaces, John Postel, the editor of the RFC series, and representatives from Apple, IBM, and Microsoft. To the Minnesota team, this is the moment they realize Gopher has become a global standard. Their computing heroes are now asking them technical questions. Even U.S. Senator Al Gore, who is promoting the information superhighway, appears in the story. He attends early networking events where Gopher is demonstrated and reportedly attends GopherCon and uses Gopher to access documents. Minnesota press accounts note that Al Gore called it an example of how citizens could one day retrieve government information directly. As Gopher space expands, new search tools emerge to index it. Veronica, the very easy rodent-oriented net-wide index, indexes every item across every Gopher server, functioning as a global search engine. Jughead indexes the hierarchy of individual servers. These tools let users search distributed information directly, eliminating the need to dig through menus.
And I can search for stuff like the thing I always searched for in demos, salmon, because I always found it. Here the server has given us back 20 out of some large number of documents.
And a detail that most people will overlook is that when Tim Berners-Lee releases the first World Wide Web code and documentation, he actually distributes it through Gopher servers. By 1993, Gopher is the dominant interface for online information. Thousands of servers, major institutional adoption, attendance from the most important figures in computing, and government use, including the White House. Gopher has reshaped the command line internet and spread far beyond its university origins, but it is still maintained by a small team inside a single institution, and the forces arriving next in the story will prove to be larger than anything the team can handle. By late 1992, Gopher is the fastest growing service on the internet. At the same time, Tim Berners-Lee is promoting the early web. Although the web is now synonymous with the internet, at this point in the story, the web referred to Tim's new hypertext protocol, a rival to Gopher that was not yet the default way to go online. At IETF meetings, Tim and the Gopher team talk frequently. Tim later recalls telling the Gopher team we're focused on the same problem. He suggests a closer relationship between the projects. The Minnesota team listens, but does not pursue the relationship. They see Gopher's menu hierarchy as clear, predictable, and easy to maintain. And Tim's project has free-form hypertext that appears harder to manage and more fragile. The discussions fade without action. The first major downward shift in Gopher's destiny occurs after this, and not through a fumbled relationship, but from a fumbled announcement about licensing. On February 11, 1993, the University of Minnesota releases a Gopher licensing policy. Educational and nonprofit use will remain free, but commercial use requires contacting the university. There's no fee schedule, no defined process, and no guidance on how these terms would be set. However, speculation begins within hours, and developers assume the worst. They pause their Gopher projects, and system administrators write that they cannot rely on software with an uncertain future. At the same moment that Gopher's licensing status becomes unclear, CERN places the web into the public domain without permissions or restrictions, and a clear guarantee that anyone can use the web and modify it. The contrast between these systems and the licensing that may influence their destiny quickly spreads across mailing lists. The web is free, but Gopher may not be. And to make things worse for Gopher, the web gains something that Gopher does not: a more graphics-oriented interface. In 1993, NCSA releases Mosaic, the first popular graphical web browser that brings images and styled pages into the mainstream, enabling users to see graphics load inside the browser for the first time. At conferences, the shift is obvious. In '93, Gopher sessions are full, but by 1994, they are half empty, while Mosaic and Web Talks overflow with attendees. Paul Lindner summarizes the reaction. Who wants text menus when you can look at pictures? Mosaic accelerates web adoption at the exact moment Gopher's momentum slows. Inside the University of Minnesota, the team tries to advance Gopher, but they already are operating at their limits. The Gopher team remains small. They maintain the protocol, respond to emails from around the world, and support thousands of servers and continue their original university duties. They release Gopher Plus, adding metadata and new item types, but adoption is inconsistent. Many administrators keep their existing servers unchanged. Meanwhile, the web community iterates rapidly. New browsers, new features, new tools. In 1994 to 1995, the University of Minnesota faces a financial crisis. Departments are reorganized. Mark Cahill, Paul Lindner, and others are reassigned to build web-based administrative systems. Gopher development effectively stops. There is no announcement or formal shutdown, The people who built Gopher are simply moved to other work as the web becomes the dominant platform. The web accelerates under an open license and a rapidly improving browser. Gopher slows under licensing ambiguity, a small team, and shifting institutional priorities. The protocol that once defined internet navigation begins to fade from view. By the late 1990s, Gopher is still online, but the ecosystem around it has become small. In 2002, Internet Explorer removes Gopher support following a security issue. Other browsers follow the same pattern. Usage declines because the default tools no longer include it. There is no shutdown, no announcement. Gopher simply becomes harder to reach. The protocol survives because a small, dedicated community keeps it alive. Once mainstream browser support disappears, Gopher moves into a niche but active space. Cameron Kaiser develops the Overbyte extension so modern browsers can still access Gopher space. He rebuilds global search with Veronica 2, indexing the remaining servers that exist. Throughout the 2010s and 2020s, individuals run Gopher holes on small, low-power machines, Raspberry Pis, inexpensive VPS instances, even solar-powered microservers. They use them for text scenes, link collections, hobby archives, and minimal personal sites. Projects like Gopherpedia show that even large knowledge sources can be delivered through simple menus. Around the same time, a broader small web movement emerges. Networks and protocols built around low complexity and personal publishing. Examples of some of these communities include tilde communities, small Unix systems where users create simple personal pages and command line social spaces. Another are Pubnix servers, modern recreations of 80s and 90s multi-user systems focused on shared text-first computing. And finally, there are some minimal protocol revivals like Finger, Gopher, Gemini, and other lightweight ways to publish text without ads or tracking. However, within this world, one protocol stands out: Gemini. Released in 2019, Gemini positions itself between Gopher and the web. It keeps Gopher's simplicity and hierarchical structure while adding encryption by default and a minimal text format. Gemini spreads quickly within the small web community because servers are easy to host, the requirements are minimal, and the experience stays intentionally constrained. Writers studying the space describe Gemini as a direct continuation of Gopher's design philosophy, a modern attempt to preserve clarity, low overhead, and personal control. Even members of the original team notice how the core ideas persist. For the team that created Gopher, watching their invention fade was emotional. I was sad when it became clear that the web, not Gopher, would dominate, Mark McCahill admitted. After pouring their hearts into what they once called the software of the internet, the team got little financial reward. McCahill moved on to other projects and eventually left Minnesota for a job at Duke University in 2007, but he still takes pride in what Gopher achieved. Decades later, he fired up a Gopher client on his iPhone and felt a wave of nostalgia. It reminded him of, in his words, what things used to be like when there wasn't an ad on everything you went to. In 2016, the University of Minnesota honored McCahill by placing him on their Scholars Walk alongside notable alumni, a formal recognition of Gopher's legacy even as the internet took a different path. And when he looks back on it, one lesson will stay with him. I understood that it was okay to do a simple thing, McCahill said. You didn't have to do something complicated. Simple could be very powerful. Thanks for watching this episode of Offline Museum. If you want more stories about hidden systems and the history of the internet, subscribe for more.